chemical equilibrium. Reactant is converting into product. Converting into product. This is one type. Second type is like this, will write. And one more type, I'll write like this. Like this. So this one, first one is irreversible process. Is a irreversible reaction. Reactants to products will form, but from products we can't get reactants back. First one, it is happening in only one direction. Second case, it is a reversible reaction. Even third case also it is reversible reaction. I'm asking what is the difference between second reaction and third reaction? Forward reaction is more favorable compared to backward reaction. It is a reversible reaction, but both are not happening in equal rates. Understood? Two people are fighting. In that first person throwing 3 stones per unit time. Rate of forward process is equal to rate of backward process. Okay, that reaction is said to be in equilibrium. Some reactions proceeds in only one direction, single direction. Those reactions are called irreversible reactions. We can't get products back. Some reactions happens in both the directions, but all the reversible reactions may or may not be in equilibrium in all the cases. At certain stage, rate of forward reaction and rate of backward reaction both will be same. That state is called equilibrium state. Let us take one example. A is in equilibrium with B. A is in equilibrium with B. No, first I am not writing. A is in equilibrium with B. Here, 3 moles of A is decomposing and producing 3 moles of B. This is a forward process. Next, what happens here? 2 moles of B, again it is converting, giving 2 moles of A. Out of 3 moles, only 2 moles of B is converting A. Here, 3 moles of A is consuming, only 2 moles of A. This process is reversible, but not in equilibrium. That is the reason this forward arrow I put long. So this is favorable towards forward direction. Forward direction, many moles are forming. Reverse direction, only 2 moles is forming. So after some time, this reaction is going to be end. Next, if I write like this, A and B both are in equilibrium. 3 moles of A is consuming, forming 3 moles of A. Again, 3 moles of A is giving back. 3 moles of B is converting into 3 moles of A. Forward direction, 3 moles it is consuming. Backward reaction, 3 moles it is forming. So there is no loss of, but there is no end for this reaction. This reaction is in equilibrium. This is not in equilibrium. Understood, students? What is the difference between irreversible reactions and reversible reactions? And also I explained difference between reversible reactions and the reaction which is in equilibrium. Okay. So now tell me, what is equilibrium? State at which rate of forward reaction is equal to rate of backward reaction. State at which rate of forward reaction is equal to rate of backward reaction is called chemical equilibrium. Equilibrium with the rate of backward reaction. Backward reaction is called chemical equilibrium. Chemical equilibrium. A is converting into B. Here, forward reaction constant Kf I am taking. Backward reaction constant Kb I am taking. Kb I am taking. Otherwise, rate with respect to rate we are writing. Rate of forward reaction Rf, rate of backward reaction Rb. So at equilibrium, what happens, students? Rf is equal to Rb. Rf is equal to Rb. Rate of forward reaction is equal to rate of backward reaction. What is rate? What is rate? Number of moles of reactants converting number of moles of reactants converting into products per unit time, or number of concentration of reactants per unit time converting into products. Otherwise, simply you can also define change in concentration with respect to time. A concentration is changing to B. B concentration is changing to A with respect to time. Rate is nothing but change in concentration of reacting species with respect to the time. With respect to the time, it's called rate of reaction. Rate of reaction. Next one. Equilibrium definition understood? Law of mass action. Law of mass action. Law of mass action. See, students, I am taking one equation and I am explaining. A plus B is in equilibrium with the C plus D. While writing equilibrium reaction, please don't write like this. No meaning. Half hook arrow we have to write. This is the correct representation, not this one. And equilibrium reaction while mentioning this length also, forward and backward reaction, these arrows are there now. Those lengths also should be equal as much as possible to maintain those conditions. Okay, students. And if you know the states of reactants, mention states also. A is yes. Mention the state of the A, B, all the reacting species. If you don't know, please don't do mistake. Let it be like that only. If you know perfectly, hydrogen is gas. You can write state of the nitrogen is solid. You can write. Is nitrogen solid? Sandra, does it exist in solid state at normal conditions? No, this gas. Okay, so that nitrogen in solid you don't write. Standard conditions only how to consider. H2O liquid. H2O can exist in solid state also, no sir, ice. But at normal conditions, what is its state? That is only the standard state. That if by applying external conditions, if you change the state, that is not correct state. Standard state you have to consider. Okay. Now, uh, according to law of mass action, rate of this is the forward reaction, isn't it, students? Forward reaction. A plus B is converting into C plus D. This is the forward reaction. It happens from left to right, reactants to products. So now rate of forward reaction is directly proportional to concentration of A into concentration of B. First of all, do you know the concentration, students? What is concentration? I have to teach all the basics I think here. If you know, tell students. If you don't know, no, because you know you need to know all these basics. I'll teach you. Don't worry. Concentration. What is the formula of concentration? Anyone? Do you know or don't know? Concentration or active masses like that areas. Daniel, no, I think. Other students. So no one is telling no means everyone knows. Now, here I am going to introduce one more equilibrium constant. Important. Equilibrium constant. Kc means equilibrium constant in terms of concentration. C for concentrations. C for concentration. So here Kc is equal to sorry Kf by Kb. Kf by Kb. Equilibrium constant. Important student. Sometimes Kf value they are giving, Kb value they are giving. They are asking you to find out Kc. Or any two they'll give. Third one they are asking to find out. Next, according to the equilibrium definition, at equilibrium, what they said, students, rate of forward reaction is equal to rate of backward reaction. Rate of forward reaction is equal to rate of backward reaction. Rate of forward reaction, what is that? Kf into concentration of A power m1, concentration of B power m2. Rate of backward reaction Kb into concentration of C power n1 into concentration of D power n2. Okay. So at equilibrium, this one and this one both are equal. Now I am going to equate these two. Kf into A power m1 into B power m2 is equal to Kb into concentration of C power n1 into concentration of D power n2. Now Kf by Kb is equal to Kf by Kb we want. No, Kc is equal to Kf by Kb means this has to come this side. This term has to go here. So what we get? Concentration of C power n1 into concentration of D power n2 by this term will come to denominator. So from this, what we can say, students, equilibrium constant is nothing but the ratio of the concentration of products to the concentration of reactants. Simply, we can write concentration of products to the concentration of reactants. If any questions are there, that will be raised. Is it clear, students? So if you take one particular reaction, M1A plus N2B. For this only we tried now. N1 plus N1C plus N2D. N1 plus N2D. M1A plus. See here, product concentration is in numerator. Reactant concentration is in numerator. Whatever the coefficients are there, that raised to the powers of the concentration terms. Got it, students? How to write the equilibrium constant for a given reaction? Copy it. Just observe. If you have any doubt, please let me know. Shall we write equilibrium constant for few chemical reactions? Actually, I wanted to give reversible and irreversible reactions. Afterwards, I'll give. I should have given first only. Let it be. Because immediately I started equilibrium and all, so I couldn't give. N2 better. I'll give now only. You should know now which is reversible, which is reversible. Reactions. Irreversible reactions. Combustion reactions. Do you think are they reversible reactions? No. Reactions are. If it is reversible reaction, no, is petrol price and all it won't raise. Hydrocarbons combustion and all. If it is reversible, we'll get it back now again. And some neutralization reactions like NaOH plus HCl, NaCl plus H2O. Some precipitation reactions, NaNO3, NaCl plus AgNO3 gives AgCl precipitate plus NaNO3. These are some examples of irreversible reactions. Next one, reversible reactions. If you take formation of ammonia, N2 gas plus 3H2 gas is in equilibrium with 2NH3 gas. But these reactions should happen in closed container, students. These conditions are important. If it is not closed container, yeah, product will be escaped. It will be escaped to the surroundings. So you can't get it back. Reactions you can't get it back. Conditions apply. It must happen in closed container. H2 gas plus I2 is in equilibrium with the 2HI. N2 gas plus O2 gas is in equilibrium with the 2NO gas. CaCO3 solid is in equilibrium on heating. CaO plus CO2. Here closed container. Closed container. All these reactions are reversible. It happens in closed container. Irreversible reactions happens only in one direction. You can't get it back. Here, first case, you can't expect any equilibrium. Reversible reactions. Okay. So we got to know some reversible reactions. For that, we'll write the equilibrium constant. N2 gas plus 3H2 gas is in equilibrium with 2NH3 gas. Kc is nothing but equilibrium constant. So just observe, students, here product concentration by reactant concentration. No? Same thing here. What is the product, students? NH3. What is the coefficient here? 2. That will be raised to the power of this product concentration. By here, 2 different reactants are there now. Product you have to take. Concentration of N2 into concentration of H2. Here there is no coefficient, means only one. So that you can keep, or you neglect also, nothing left. More than one is there, you have to write. Here, hydrogen is in 3 moles, no? That you have to write on the powers. Got it, student? That is only equilibrium constant. Product concentration. Sometimes they'll give values of NH3, N2, H2. Substitute and find out Kc value. Next, H2 plus I2 gives to H. Here Kc is equal to H2 concentration of I2. Yes. Kc is equal to concentration of CaO into concentration of CO2 by concentration of CaCO3. But in case of solids, what you know, their concentrations are unity, same, almost same. We'll consider only one. Kc is equal to CO2 with right. See, solids and all no need to consider. You can cut it. Can you write equilibrium constant of this one, students? N2S plus O2S is in equilibrium with 2NOS. Here what we get, students? O2. Sandra, correct answer. Sometimes they'll give the values and they. Next one, characteristics of equilibrium constants. Constant. Equilibrium constant. Characteristic properties of equilibrium constant. Daniel, in case of solids, their concentrations will take for unity. Their like one only will consider, so that we can cancel it. There's no much difference in the concentrations. Because how many moles of CO2 I didn't cancel. Why didn't you cancel CO2? CO2 means it is gas now. It won't occupy a definite volume. Its volume will change. So you can't take always unity. Yes. Next one. First one. Equilibrium constant. Higher the value of Kc, higher the value of Kc. Higher the value of Kc means, can you tell students what is the conclusion? What it implies? Higher the value of, not conclusion, what it implies? If Kc value is more, what it implies? Means Kc value, just observe the formula, Kc value when it will be more, if
Concentration of the
concentration
product will
more.
be increased.
Correct, no? If product concentration is more, then only Kc value will be more. If Kc value, suppose if I consider 10 power 3, means product concentration 1000 times more than the reactant concentration. Means rate of formation of product. Means this reaction is almost going to completion. Product Kc value is too high, means reaction is going to finish. Forward reaction is more favorable. Kc will be maximum only when the concentration of products is high. Okay, reaction is going to be completion. Complete. If Kc value is 1, Kc value is 1 exactly. Tell me, students.
Concentration of the products and the reactants will be same, equal.
Same. Same means rate of forward reaction and backward reactions are in equal speed. So this reaction is not going to end. It's not going to end. If K less than 10 power minus, sorry, is equal to 10 power minus 3. This time, backward reaction is dominating. Yes or no, students? Your product concentration is lesser than reactant concentration. So, backward reaction is predominating. Predominant. So, extent of equilibrium can be decided by knowing Kc value. If it is equal to or greater than 10 power 3, reaction is about to finish. If it is exactly equal to 1, reaction is in equilibrium. If it is equal to 10 power minus 3, backward reaction is predominant. Forward reaction is not so favorable. This reaction is very hard to proceed. Next, one more point I am going to give. Equilibrium constant does not depends on change in concentration of reactants or products. Kc does not depends on change in concentration of reacting species. Equilibrium constant does not depend on change in concentration of reacting species. I'll explain this point to see students. A is converting into B. A is converting into B. 5 moles of A is converting into 5 moles of B. Here equilibrium constant. How can we find, student? Per unit volume, you take 5 by concentration of B 5, concentration of A also 5. So it will get cancelled in 1. Second, this is case 1. Case 2, what I did, here I am increasing the number of moles to 7, means I am increasing the concentration of A per unit volume. That time 7 moles of A is decomposing and forming 7 moles of B. In order to maintain the equilibrium, 7 moles of B will give 7 moles of A. Isn't it, students? Because reaction is in equilibrium. We are only telling, no. Reaction is in equilibrium. So here Kc value, how we will find out? Concentration of B is 7. Concentration of A is also 7. So ratio how much? It is 1. Got it, students? Is there any change in Kc value? Kc is the ratio. Kc is the ratio. It will remain constant. No change. Okay. So equilibrium constant does not depends on change in concentration. In 1 year CIT examination, it was very difficult. Almost it was difficult than JE exam also. Karnataka CET exam. Sometimes it happens. That year they asked one reaction they had given, and they told concentration of iodine is increased to 2 units, concentration of hydrogen is increased to 2 times, and beginning concentration Kc is 64. What would be the Kc dash? Means new equilibrium constant. Most of the students, they did some calculation and they put some other value. Actually, there won't be any change. It will be like say, this ratio will be remain same. That ratio remain same. I'll give one more example. Students. Earlier I have given one fighting example. One person is throwing 3 stones per unit time. The other person also throwing same 3 stones back to the first person. Both are in equilibrium. First person got angry. You are throwing again same. So he increased to 5. That person also want to means he has to maintain that equilibrium. No, again he started throwing 5 stones per unit time. Understood? So earlier 3 by 3, 1. In the second case also 3 or 5 by 5, 1 only. Understood? Is there any change in equilibrium constant? The equilibrium constant is the ratio of product concentration by reactant concentration, right? So it will not change. That meaning I've given this point. Understood, students? Equilibrium constant does not depend on change in concentration of electron species. Next one, catalyst does not affect the equilibrium constant. Generally, catalyst what it do, students? It increases the rate of reaction. If it increases the rate of forward reaction, it also increases the rate of backward reaction, because by decreasing the energy barrier, it is increasing the rate of reaction. Suppose here reactants are there, to convert into products, they have to reach to this barrier. This is called transition state. So whatever the reactants reach this barrier, those reactants only can be converted to products. Catalyst, what it will do, this will decrease the height of the barrier. Here, from here to here only some reactant molecules could reach. If we decrease the height of the barrier, many reactant species can reach state. Suppose pass mark is for 50 marks. pass mark we put for 50. Only few students can reach to that target. So only few students will get pass. If we decrease because of corona, omicron, demicron, so many are coming now, butterscotch, strawberry, vanilla, and all. So because of that, if they reduce, if government reduce or educational minister reduce the barrier pass mark, many will pass. Their intention is they want to pass everyone. Okay, same thing here. Catalyst does. So catalyst does not affect the equilibrium and does not affect the equilibrium constant also. Just it will help to attain the equilibrium faster. Sometimes high jump and all with C. In high jump they do some this spark it's something there. No, I don't know properly. That height if they increase slowly one by one will get eliminated because they can't reach. If we decrease the height of this target point, they many people can jump. Once if we increase number of students, cost will be decreased. In that way, they eliminate the high jump people. Same thing. They are also energy activation energy. Only some people, very few people will have more activation energy to cross the highest barrier. Those people can considered as high jumpers, best jumpers. Okay, same thing here. Catalyst does not affect the equilibrium constant. It will be next. One more point I am going to give students. Here, A is in equilibrium with B. Here, equilibrium constant Kc I am taking. Observe students, you while explaining, please don't copy it. Next, if I multiply this system with any factor, I am multiplying with the 2. How do this Kc dash new equilibrium constant how will get? Just for the previous one, which factor you are multiplying the entire equation, that factor you raise to the power of the previous equilibrium constant in order to get new equilibrium constant. Understood, students? I multiplied with the 2 from here. This is the first one. This is a new equilibrium. Here Kc I know. Kc dash they are asking. For this they are asking. If you know this value 2, to get this Kc dash, you just put 2 power 2. Only so much. If you multiply equilibrium with any factor, that new equilibrium constant, in order to get new equilibrium constant, you just raise the power that factor, you just make it the power of first equilibrium constant. That factor will be raised to the power of first equilibrium constant in order to get constant, in order to get new equilibrium constant. Clear, students? Half A is in equilibrium with the half B. This one is Kc, this one is Kc dash. What is the relation between Kc dash and Kc, students? Kc dash is equal to very good. Kc power 1 by 2. Otherwise, square root of Kc. Understood, students? Here we multiplied from here to here. We multiplied with this factor that will be raised to the power of previous equilibrium constant. Next. Is it clear, students? N2S plus 3H2S is in equilibrium with 2NH3S. Its equilibrium constant Kc its equilibrium constant Kc is equal to X. Next, of N2S plus 3 by 2 H2S is in equilibrium with NH3 gas. Tell me students, Kc dash is equal to above the reactions to observe the reactions properly from first one to second one, what they did, what change you observed. Sandra, correct answer. Other students, I'm expecting answer from many students. Sandra already sent her answer. Tanmay, correct answer. Kc dash is equal to. Tanmay, correct answer. Observe the reactions, students, two reactions. Shraddha, correct answer. You can type it and you can, in words also you can write them. Very good. Aniketa, correct answer. Root of square root of x or Kc power 1 by 2. That is correct answer. Very good. Hope this property is clear. Next one. A is in equilibrium with B. Its equilibrium constant Kc. B is in equilibrium with A. Its equilibrium constant Kc dash. Then what is the relation between Kc and Kc dash? Now Kc dash is equal to 1 by Kc. Forward reaction equilibrium constant, you know. Backward reaction equilibrium constant they are asking. So from this what we can say, equilibrium constants of forward and backward reactions are reciprocal to each other. Equilibrium constants of forward and backward reactions are reciprocal to each other. Reciprocal to each other. Understood, students? These are the characteristics of equilibrium constants. Next one more term I am going to introduce, QC. QC. That is also called reaction coefficient. QC. I'll write the equilibrium constant and Kc for both the reactions. I'm selecting one reaction, N2 plus 3H2 . Now here I use QC. H to power 3. Here Kc I am writing. Tell me, students, what is the difference between this QC and KC? See, above reaction, the is the just observe the arrow marks. First reaction and second reaction. Are they equal? Tanmay. No. Then why did you tell equal? So the first reaction is in first reaction not in equilibrium, isn't it? Not in equilibrium. Second case, it is in equilibrium. So second case also you can use QC. Second case also you can use QC. But first case you cannot use KC. KC, now I am going to give, now I confused you. I am going to give clarity. You don't worry, students. KC when we use, if the reaction, reversible reaction is in equilibrium, then only we will use. QC can be used at any extent of the reversible reaction. Tanmay, arrow forward reaction, you are only telling arrow forward reaction is longer means reaction is favorable towards forward direction. Means rate of forward and backward reactions are not in equal speed, not in equilibrium. One side it is favorable, one side it is not favorable. That long arrow towards forward direction shows that side it is more favorable reaction rate. Got it, students? So QC can be used at any condition of reversible reaction. KC can be used only when the reversible reaction is in equilibrium. Is it clear? But while representing, while writing, while calculation, everything will do same. Understood? QC is a reaction quotient is used at any condition of reversible reaction. KC we are using means reaction in equilibrium. So by knowing QC and KC, we will decide whether the reaction is in equilibrium or not in equilibrium. If it is not in equilibrium, forward reaction is more favorable or backward reaction is more favorable. Now we are going to relate QC and KC and how to decide whether the reaction is favorable towards forward direction or backward reaction. First, if important students, QC is equal to KC, what it means? Reaction is in equilibrium. This one condition I'll explain. Afterwards, I'll give little break, students. Reaction is in equilibrium. If QC is less than KC, what is it mean, students? QC is less than KC means product concentration is less than reactant concentration. QC is less than KC. QC we will find like this. QC value when it will be less, product concentration is less. In order to maintain equal concentration, reaction will equal rate, reaction will proceed towards forward direction. Forward direction. Here, this shows these reaction rates are not in equal. How it is telling? Product formation somewhat lesser compared to reactant. In order to maintain equality, what it will do? For product concentration, it try to increase. Product concentration, it try to increase to reach the equilibrium. So that time forward reaction is more favorable. Otherwise, simply if QC is less than Kc, reaction is moving in forward direction. If Kc value when it will be more, students, otherwise like this also you can decide. Kc value when it will be more, if product concentration is more, isn't it? Product concentration when it will be more, if it is moving forward direction. Understood? If QC is greater than Kc, Kc value, just observe every time Kc value, otherwise. First explanation, if you find difficult, second explanation you consider, it will be easy for you. QC is greater than Kc means Kc value is less, they are telling. Kc value less means product concentration equilibrium is less. Less means backward reaction taking place. Reactant side it is moving. This is simple process. Understood, students? How to decide whether the reaction is in equilibrium or not in equilibrium? If it is not in equilibrium, forward reaction is more favorable or backward direction it is moving, can be decided. This is the QC and KC. So here what I explained, students, reaction quotient means Kc can be used when the reversible reaction is in equilibrium. QC can be used at any extent of reversible reaction. By comparing QC and Kc, we can explain the status of equilibrium, whether it is approaching or forward reaction is favorable or backward reaction. Understood? Okay, students. So another term, reaction quotient, I introduced, and what are the applications? What are the application of QC also? Next one. Next one. KP. KP. Nothing here. KP is nothing but equilibrium constant in terms of partial pressure. In terms of partial pressures. Equilibrium constant in terms of partial pressures. See, students, so already Kc we have no. What is the necessity of introducing Kp? There is some problem, students. Gases, they won't occupy definite volume, I said. Gases, they won't occupy definite volume. So gases concentration, we can't say number of moles per unit volume and all. We can't means accurate value we won't get. Accurate value, those are options. So what they are doing, gases concentration they are measuring in terms of pressures. Individual gases pressure if they find, that is called partial pressures. Partial pressure. How much pressure it is exerting on particular gas, how much pressure particular gas B is exerting. So in terms of pressures, they are considering more pressure is there, mean more concentration of gas is there. When it exerts more pressure, if more volume is more quantity is there, yes. Okay. So in terms of partial pressures, they are finding equilibrium constant. That is only Kp. Kp. So how to write? Almost process will be same. So nothing is there different. N2 gas, mainly this is applicable for gases. If all the reactants and products are gases, we use this one. Three gas. Kp is equal to, earlier we used square bracket, no, here not required. P we use. P of NH3, coefficient is there, that will be raised to the power of P by partial pressure of nitrogen into partial pressure of hydrogen whole power 3. Yes, there we use a square bracket concentration unit. Here means active masses we used over there. Here only P of NH is square. Since coefficient is 2 here, or P of N coefficient is 1, so no need to write. Here is 3. I wrote it. Next one, N2S plus O2S is in equilibrium with 2NOS. 2NOS. Here, partial Kp, if you want to find partial pressure of NO whole to the power 2 by partial pressure of nitrogen into partial pressure of gases, we are getting some error. If we find Kc, so we are using, instead of concentration, we are using partial pressure. That number of moles per unit volume concept will not be applicable perfectly to the gases. Students, do you know ideal gas equation? PV is equal to nRT. PV is equal to nRT. If you don't know, I can't relate to Kp and Kc. To PV is equal to nRT. From Boyle's law, Charles' law, don't know. Yeah. Boyle's law means combined gas. Boyle's law means pressure is inversely proportional to volume. Charles' law, volume is directly proportional to temperature at constant pressure. And Avogadro's law, volume is directly proportional to number of moles under identical conditions of pressure and temperature. By combining all these laws, we get one equation that is called ideal gas equation. Ideal gas equation. If you want, I'll write the formula and I'll explain the terms. You are comfortable. P is pressure, you know. V is volume, you know. N is number of moles. R is gas constant. T is absolute temperature. I will make it a little simple. Relation between derivation I am not going to do. Just I'll give one simple formula. Instead of explaining entire these all these formulae, I'll explain one simple thing. By using this, you can find out KP-KC relation. Relation between KP and KC. Some error will be there, I said, no, from equilibrium to equilibrium. What is the error? We'll see. Here, KP KC relation, KP is equal to KC into RT power delta N. Here, R is gas constant, its value is fixed. Value is fixed. Here, delta N gas we have to take. What is delta N? This is very important, student. Delta N is nothing but sum of the number of moles of ACS products minus sum of the number of moles of ACS reactants. I'll explain how to find out delta N. First, write this relation. Kp is equal to Kc into RT power delta N. Kp is equal to Kc into RT power delta N, where delta N is nothing but number of moles of ACS products minus number of moles of ACS reactants. gaseous reactants. See students, I'll take one example. N2S plus 3H2S is in equilibrium with the 2NH3S. See students, how to find out delta N? Okay. N is number of moles of gas. N don't want. Kc is equal to Kp is equal to Kc into RT power delta N. Delta N I am explaining anyway. R is gas constant. T is temperature. Even temperature will substitute. Only so much. Kc they will give. Kc already you know how to find. But they will give. Kc if they give, Kp they lost. Kp if they give, Kc they lost. Tanmay, got it. Delta N how to find out? I am explaining now. Only depends on delta N. This entire thing. How to find out delta N? If I explain, easily you can answer the questions upon this topic. So now delta N is equal to sum of the number of moles of gaseous products. Only gaseous products you have to take. How many moles of gas is there? Students here, product side 2. Reactant side, here there is 1 mole of gas and 3 moles of gas. Okay. React products minus product is right side minus reactants right side, left side. How much will get? Minus 2. Minus 2. See, ma, Kp is equal to Kc by RT we can write now. After dividing with certain factor, I told you these two are constant and positive values only. So after dividing with certain factor, Kc is equal to Kp, means which is more? I think we did mistake. Kc into RT power minus 2, no? So Kc. Shraddha, your Shraddha is correct. You told your Sandra. Now it is correct. Kc is greater. It is like 2 is equal to 4 when we divide with 2. Correct? No? This is like Kc for Kp. This is like Kc. This is the RT factor. Like this you consider RT factor. So which is greater? Kc is greater. Sorry, Shraddha. You are correct. Kc is greater than Kp here. So here, so Kc is this relation shows Kc is greater than Kp. Next, one more thing I am given. PCl5 gas is in equilibrium with PCl3 gas plus Cl2 gas. Shall we do the relation? Shall we get the relation here between Kp and Kc? Delta N, if you find product number of moles 1 plus 1, 2. 1 mole of PCl3 gas, 1 mole of Cl2 gas, 2. Minus product reactant side only 1 mole of reactant, right? So here 1. 1. Now Kp is equal to Kc into RT. After multiplying with certain factor, Kc is equal to Kp. So which is greater? Kp is greater. From this, what we can say? In this relation, Kp is greater than Kc. Tanmay, which one? First one or second one? I gave an example, no? Here, you better write like this, Tanmay. Kp is equal to Kc RT power minus 2, you just make it RT power 2. Second one.
Okay, sir.
Second one, it is not Kc. Kp is greater than Kc. Second one, Kp is greater than Kc. I didn't tell Kc is greater than Kp. Here Kp is greater than Kc again. Tanmay got it? Okay. So here after multiplying certain certain factor, Kc is equal to Kp. Next, one more example I'll give. You only tell me the relation. N2 gas plus O2 gas is in equilibrium with the 2NO gas. Tell me the relation between Kp and Kc. Product number of moles 2. Reactant, this one is gas, only 1 mole. This one is gas, 1 mole. 2 minus 2, 0, right? Now Kp is equal to Kc into RT power 0. Anything power 0 is equal to 1. So now Kp is equal to Kc. They are asking among the following which system Kp and Kc both are equal. Among the following in which system Kp is greater than Kc, Kp is less than Kc. That they are asking. If delta n is equal to 0, Kp and Kc both are equal. If greater than 0, I told you, greater than 0, Kc will be greater than Kp. Less than 0, Kp will be greater than. Okay. This is the relation between Kp and Kc. Kp and Kc. Next one, characteristics of equilibrium. Equilibrium constant over equilibrium. Just 1 or 2 points I'll give. And last 5 minutes you tell me, students. Will recall the topics, whatever I explained today. Things will recall. Equilibrium constant. So not equilibrium constant, only equilibrium. Equilibrium, chemical equilibrium is dynamic in nature. What is the meaning of dynamic, students? I'll give one more dynamic, changing or doing continuously. Means converting, your meaning is also correct. What you said, Tanmay. Changing from one form to another form. It is happening continuously. Static equilibrium. It is not changing, it is not moving. Here, earlier I had given no, A is converting into B, B is converting into A. Both are happening in equal rates. That is an example of dynamic equilibrium. There, the equilibrium is in that the equilibrium is called dynamic equilibrium. It is in moving but maintaining same rate. Next, one wood I put it in water. It is floating. It is not sinking. It is staying. It's maintaining equilibrium with water and but it's not moving anywhere. That is called static equilibrium. Static equilibrium. There are two cases: dynamic equilibrium and static equilibrium. So this chemical equilibrium is always dynamic in nature. Chemical equilibrium always dynamic in nature. Dynamic equilibrium. Next one, equilibrium can attain any. Equilibrium can attain either of the directions. Means it can attain through the reactant direction, or it can attain equilibrium through product direction. I'll explain here. A is converting into B. A is converting into B. So here 5 moles of A is converting into B. Here only 3 moles of B is giving back 3 moles of B is converting into A. Is it does it in equilibrium, students? Does it come under equilibrium? No. So in order to attain equilibrium, reactants, this concentration can be decreased to 3 one way, or this concentration can be increased to 5. Dissociation concentration can be increased to 5. So the better example is there for us. Fighting scene is there now. 3 stones. First person is throwing 3 stones. Second person is getting, again he is throwing 3 stones. Equilibrium. First person is throwing 4 stones, but second person is throwing only 3 stones. First case they are in equilibrium. Second case they are not in equilibrium. To attain equilibrium, anyone, suppose those who are throwing more stones, they can reduce the number of stones so that they can balance both. Or those who are throwing back less number of stones, they can increase the number of stones. So the person who is throwing 4 stones, if you maintain 3 stones per unit time, they will be in equilibrium. Otherwise, first person is throwing 4 stones, second person is throwing back only 3. If we raise one number, they will be in equilibrium. So this attainment of equilibrium can happen either direction, either of the direction, reactant side or product side. Got it, students? If rate of forward reaction is less, backward reaction is more. By increasing rate of forward reaction, we can it can attain equilibrium. Or by decreasing the rate of backward reaction, it can attain equilibrium. Got it, students? So, attainment of equilibrium can happen either direction of the reaction. Either direction of the reaction. And catalyst does not affect the equilibrium. Just it increases the speed of attainment of equilibrium.